This is the 3.B.2 homework, 4.32 and 4.34 from the Cheng book. 4.32 asks us to identify if these ions are Bronsted bases or Bronsted acids. So remember, if it can accept a proton, it's a Bronsted base. If it donates a proton, it's a Bronsted acid. Well, phosphate has no hydrogen in its formula, so it can't donate a proton. But if you did put protons on there, you could put as many as 3 protons on there. So phosphate is a Bronsted base. Chlorite is also a Bronsted base. It has no H's in its formula to donate, but it could take an H and become HClO2, the weak acid, chlorous acid. So it's a Bronsted base. Ammonium, there's no more space on ammonium to add more H's, NH4+. The nitrogen is totally surrounded with H's and has no extra space for more H's. So you can't make NH5 2+, but you could take H+ off of NH4+ and make NH3, so that makes NH4+ a Bronsted acid. Bicarbonate can actually accept a proton, become H2CO3, or donate a proton and become CO3 2-. So that would make it both, and the term for that is amphoteric. Okay, writing some, the second question here, 4.34, writing some molecular, complete ionic, and net ionic equations. This is the way that you often see acetic acid written. I prefer HC2H3O2, but a lot of books and the AP test might use CH3COOH. Acetic acid plus potassium hydroxide is going to make potassium acetate and water. Acetic acid in the complete ionic should be unionized because it's weak. KOH should be dissociated because it is a strong electrolyte. Potassium acetate is soluble, so it is also dissociated as K+ and CH3COO-, and then the OH- takes a proton off of the acetic acid to make water. So if we take the net ionic for this, we drop out the K+ as a spectator ion, we get acetic acid molecule, and OH- ion makes the acetate ion and the water molecule. This is the diprotic acid carbonic acid, H2CO3, so it's going to take 2 moles of sodium hydroxide to neutralize it and make sodium carbonate and water. The carbonic acid is not ionized because it's weak, but the sodium hydroxide is dissociated. The sodium carbonate is also dissociated, and you make 2 waters. So the net ionic is that the H2CO3 molecule reacts with 2 hydroxides to make carbonate and 2 waters. This one is not acid-base. It is a precipitation reaction. It starts with ammonium carbonate and calcium chloride. The precipitate ends up being calcium carbonate, and ammonium chloride is a soluble second product. So if we dissolve the ammonium carbonate, we get NH4+ and carbonate. The calcium chloride dissolves, gives me calcium 2+ and 2 chlorides. The calcium carbonate does not stay dissolved, it precipitates. The ammonium chloride is soluble. So the net ionic is just the carbonate from the ammonium carbonate and the calcium from the calcium chloride precipitating calcium carbonate.